Okay, so question 6 gives you the graphs of y equals cos x and y equals a sine x. And they tell you that a is a real constant, so is an element of the real number sets, and it gives a point of intersection x equals pi on 3. Find the value of a. So if we just substitute in x equals pi on 3, we're going to find cos of pi on 3 equals a sine of pi on 3. Now if we set up our triangles, the pi on 3 angle is the same as 60 degrees, so it's the bigger one in here. So it's opposite root 3, that's 1 and that's 2. So cos is CAH, so cos of 60 degrees equals the adjacent root 3 on, the adjacent 1 divided by the hypotenuse of 2, so hypotenuse is that guy, and then sine is given by sine of 60 degrees equals the opposite root 3 on the hypotenuse of 2. So we can rewrite this out as cos of pi on 3 is a half equals sine of pi on 3 times a, so sine of pi on 3 is this root 3 on 2. So solving for a, we get a equals 2 by a half, so root 3a still, equals 2 by a half, so root 3a equals 1, so a equals 1 divided by the square root of 3. And that's our answer for this question. So if x is an element of 0 to 2 pi, find the x coordinate of the other point of intersection of these two graphs. So we've got cos of x equals root 3, just double check that, so 1 on root 3, sorry, of sine of x, 1 on root 3 of sine of x, and it's between, importantly, 0 to 2 pi. So for this type of question, we're always going to want to combine sine and cos into tan. So to do that, we're going to divide both sides by cos of x, divide by cos of x, and we're going to get that 1 equals tan of x multiplied by 1 on root 3. So when we times both sides by root 3 times by root 3, we get tan of x equals root 3. Technically root 3 on 1. So now we draw our triangle again, and we find that this is 60 degrees or pi on 3, that's root 3, that's 1, that's 30 degrees or pi on 6. And we're looking for tan, which is opposite on adjacent, so tan of our angle equals opposite equals our opposite here, root 3, on our adjacent, which is 1. So therefore theta is the 60 degrees or pi on 3 angle. So now we know that our reference angle equals pi on 3, and now we've just got to work out where tan of x equals positive root 3 over the domain 0 to 2 pi. So luckily for us, the period hasn't changed, so it still has its usual period of pi. So we go all the way around here to 2 pi, and now we just got to see in that revolution where is tan positive. So CAST, so tan's positive in the first quadrant. Oops, in the first quadrant and the third quadrant. So the symmetries for those is theta and pi plus theta. So therefore, x is equal to theta and pi plus theta, pi plus theta, where our theta is this guy over here. So therefore, x is equal to pi on 3, and x is equal to pi plus pi on 3, which is going to be 4 pi on 3. So the other point of intersection is x of 4 pi on 3, because the previous point was x of pi on 3. So the other one must be this solution right here.